next unit is called trig identities. Okay, so we're going to be doing a lot of stuff on this formula sheet this time. Okay, so this first outcome talks about us using angles of 15 and 75 degrees. Okay, so let's go to our unit circle to start this out. Okay, so 15 degrees. Let's put some tick marks here. 15 degrees. You write this on your own formula or wherever you're going to look at a unit circle. Then the next is a 75 degree angle. Okay, what about these two missing angles in this quadrant? What do you think this number would be over here? Anybody got a value there? 105. Okay. What about the increment here above the 180? 165. Past the 180. 195. Right before 270. Are you done, Nicole?
No, me and Jenny are just sharing the unit circle.
Okay. 255. Right after 270. 285. And then 245, right? 345. Did I say 245? Sorry, I wrote 345. Does that count for anything? Okay, now we're going to have to do that whole concept in radians. Okay, so here's what I need to understand. 15 degrees is 180 divided by what? Does anybody know? What would you have to divide 180 by? It will be, but I'm just saying in a number sense. 180 divided by how many? Anybody know? 12. If I take 180 degrees and I divide it by 12, that's how I can get 15 degrees. Okay, so guess what? 15 degrees is going to equal pi over 12 as a radian. Okay. We're not going to have coordinates on this, so I'm just going to write it on the outside. What is completely over here at the side? Pi. So what would I think in my head, though? 12 over 12. Okay. What do you think about this top? How many over 12 would be at the top, right at top? 6 over 12. So what do you think this is? 5 pi over 12? What do you think this one is? 7 pi over 12? Okay, we said the flat way over here, right across, is 12 over 12. So 165 is 11 pi over 12. And then 13 pi over 12. If I was straight on the bottom, what are you going to have there? 18, right? Does that make sense? 6, 12, 18, 24, right? So if the bottom is 18, then we have a 17 over 12 and a 19 over 12. And then the whole circle is 24. So the last would be a 23 over 12. Okay, so this outcome, we're going to work with all of those angles. Always, you have to know an angle's in a degree and a radian. Okay? Okay, so have that ready so we can not have to do this every single time. Okay. So we've been working with this unit circle. We know how to do 45s, 30s, 60s. We know how to find trig values, coordinates. With 75 and 15, we don't. So we're going to figure out how to use these numbers to get those. So how can I get a 15 using the numbers that are on my original unit circle? I'm going to go like that. If I take the 45-degree angle on my unit circle and subtract a 30-degree angle, that's 15. How can I get a 75-degree angle? If I add them. Okay, I'm not going to worry about in radians. We obviously know how to talk in radians versus the degrees. Okay, here's the first question. Give me the sine of 15. First step, how are you going to figure out a combination to get 15? We're going to talk about 45 minus 30. So this is what I'm going to be doing. I'm going to find the sine of 45 subtract 30. I still have the sine of 15, right? I just wrote it differently. Okay, now we're going to go to our formula sheet. This says the sine of two angles that are subtracted. Okay, can you find this spot on your formula sheet? The sine of two angles subtracted. Everyone's found something that looks like that? Okay, so I'm going to write this. If you want to write it, go for it. So that is the formula, and I just looked on my formula sheet, and that's what it says. Okay, so in this situation, 45 would be our first angle, 30 would be our second angle. So I'm going to go sine 45 cos 30, subtract cos 45 sine 30. All right, so this is the part that's new for us. Having this formula we've never worked with. Okay, I need to fill in. I'm going to have 4 values there. Okay, I always do this because I like to make things easier on myself. So here's my trick. You don't have to do it. When I look at a 45-degree angle, sine and cos, I don't care. They're both the same, right? So that's why I always do 45 degrees. I just fill in root 2 over 2. Okay? I don't even have to think about it because they're both root 2 over 2. Okay, so that's what I like to do first, just so I don't have to think about it. What's the cos of 30 degrees? Cos is which one? The x part. So the cos of 30 is root 3 over 2. which makes the sine of 30 the 1/2. Okay, all stuff we know from last. Okay, so this is root 6 over 4. That's how you would do the math on it. Minus root 2 over 4. And then, because they're both over 4, you can just write them as a fraction together like that. Okay, we're not quite done. I need to understand astica. So we were at 15 degrees, right? What do you know about the sign? Should it be positive or negative there? Positive? So I'm good. I can just leave it, because if it was negative, I would have to change it. But because it's positive, good, we're done our answer.
Could you simplify that more? Could you actually see 6 minus 2 and then that would be root 4 over 4? Would it be 4 over 4?
No, you can't simplify roots like that. It would be it'd be like you telling me that that was a root 5. That's not mathematically a root 5, right? 3 subtract 2 is not a value that's the same as a root 5. Does that make sense? You can't put roots together if they're not the same root. Yeah. Does that make sense right there? A little bit. Okay, let's try to learn. Okay, let's try number 3 next. Yeah, let's do number 3 next. Okay, ready? Figure out where you are. Do you remember where we were with that? 23 over 12.
Oh.
Everyone pick this spot? Okay, now, can you tell me the amount? Is it a 15 or 75 amount? What do you think? We're a 15 degree. So we're a 15 degree amount of a reference angle. Okay, so then we're going to pick a 45 minus 30. Okay. What do you think about using secant? 45 minus 30. Okay, what do you think about using secant? Probably not good, right? What should I use instead of secant? Cos. So we're going to use cos of that. Okay, you ready? You gotta go find a formula sheet. Formula that matches you saying the cos of 2 subtraction angles. Okay, did you get a formula that looked like this? Cos angle, plus sine angle, sine angle? Okay, so that was from my formula sheet, and I matched it up. All right, now I'm going to give myself 4 spots to put numbers, right? Okay, I like to cheat and I put my 45s in because 45 angles, I don't even need to think. At 45, everything's a root 2 over 2. The cos at 30, that was the, when you're looking, the x number at 30. The sine at 30, so when you look at it, should be the y value at 30. So now I'm going to go with root 6 plus root 2 all over 4. That's a root 6, that's a root 2, and everything's over 4. Okay, now here's what we need to do different on this question. We just worked with the cos, but I didn't want that. What did I want? I wanted the secant. So what am I going to do to my answer? I have to flip it. So I'm going to flip it. So I like that number instead. Now, let's talk about our astica. Do we have to negate this or not? So what do you think? I think we're in this quadrant. So, cosine? Good. We don't have to do anything, so we can leave it. Cosine's positive. Good to go.
So, how do you know if it's positive or negative?
I'm in my astica, the C quadrant, so cos is positive. Because remember where we said we landed right there, so we're in that quadrant. Okay, one more, and then we'll, like that. Okay, 555. Can you figure out, this is obviously going past 360, so I'm going to go full circle and then what? Can you mathematically subtract 360 from that? Somebody say 195? So I'm landing there. Okay? Now, what's our reference amount? Are we a 15 away or a 75 away? I think we're only 15 away, right? I'm picking all these subtraction ones right now. Okay, so if I'm 15, I'm going to subtract. Okay, we like the formula we picked? Did you find it on the sheet? We're going to have a sine 45 cos 30, subtract a cos 45 sine 30. Okay, don't memorize it. Look on your sheet.
Do you have to memorize these?
Nope, you fully will have that sheet on your test. Okay, I got my root 2's over 2's because I didn't need to think about where they were going. So the cos of 30, I need to think about that number. And the sine of 30, I'm going to be thinking about that from my formula or unit circle sheet. So I'm getting root 6 minus root 2 over 4. Nope, this won't be. They all seem to have lots of root 6s and 2s and 4s. That's in common usually. Okay. Ready? What do we have to do at the very end here? Astica. What do you know? We're over here.
Sign can be positive. You can just.
Sign is negative here, right?
Yeah.
So here's what I'm going to have to do. I'm going to put brackets around that number and put a negative on it.
That's it?
That's it. Then I'm done.
Oh.
But if somebody tried to do this, they're wrong, right? Do you understand why this is wrong? Because now you're just telling me you're negating this number, but I want you to negate whatever that whole number was, okay? So throw it all in brackets and then negate it. Because somebody might see this, somebody might see that, and it's just because they put the negative through or whatever, right? That's okay. But you don't need to go that complicated. Just put brackets, negative, done, right? Okay, flip one page. We're gonna do 3 questions on this page and done.
And that was that?
Yeah, I think I'm gonna do the tan stuff tomorrow maybe. Okay. Do I have this spot? Is it good? Next page? Okay. All right, this is a formula that got expanded. Can you tell me which formula you think I used? So which formula has a cos plus a sine? This one? You see that it matches this? Cos plus a sine. So what's the original formula? The cos of 2 angles subtracted, A minus B. So the cos of that. See how I'm kind of just working backwards of what we did, right? Okay. Now, what is 80 minus 50? 30. And what is the cos of 30? So looking at your unit circle, when you look at 30, what's the x value? That's your answer.
The whole thing or just on one side?
What's that?
The whole answer or only
That's it.
But we didn't even use any of the sign.
Because we contracted the formula. This was the formula expanded. Did you see what I did? Let's start. Cos plus sine is this formula. So I took it from an expansion, just putting it back together.
Yeah, okay.
Yeah. Okay, number 2. Can you find a formula? It's got a sine cos, subtract a cos sine. Sine cos, subtract a cos sine. What do you think? Sine of the sine subtraction one? Are we good? It's a sine subtraction? Sine of a subtraction. So that's the formula it matched? Yeah.
Does this stuff be complicated?
What's that?
How does this stuff be complicated? I know there's a way.
This is it. It's like puzzling it together. That's all this is. It's like puzzling it. Okay?
But they're all under the same one.
60 degrees. Are we there? Unit circle. We're there. 60. What's the y coordinate is what you're trying to say, right? What's the y coordinate at 60? Root 3 over 2. Okay, last one. Okay, what formula? This is a cos plus sine sine. So which formula is that one? Cos cos plus sine sine. Did you get a subtraction? That's good. Have you found the match? Okay, can you simplify? What's 11 subtract 7? So that's 4 pi over 24. Can you reduce this fraction, as in divide everything by 4, which would become pi over 6? I didn't get too crazy here. I currently have the same answers. Pi over 6 is there. You're looking, and you're looking for a cos, so you're looking for the x value, which is? Okay, your answers aren't always going to be that. I don't know why I have the...
Well, did you do